So this is where the fun begins, and now we're going to actually change and experiment with this model. In this experiment, we're going to try and see the impact of changing the density of your neurons in your dense layer. First, let's run this as is to understand the numbers in terms of the loss. So let's come here and run this real quick. So these are the default parameters. So we're kind of trying to set the baseline here. All right, there you go. So let's run the loss function here. Okay, perfect. So this is the baseline for this experiment. So 3 something, 14 something, 1200 something, and shy of 2500. All right, so now what we're going to do is we're going to reduce the density of the dense layer. So make it a little bit shallow. So we're going to start at 48 on the first layer, and then we're going to significantly reduce on the second layer. We're going to make it 16, and then we're going to leave the last layer, obviously that cannot be changed. So let's see how this performs. So what we're trying to understand is how the density impacts the learning of your neural network. All right, let's compile this. Now as you can see, the number of parameters have changed. Obviously, as you change the number of neurons, the number of parameters also change. By changing the optimizing function or by changing the activation function, there is no impact on the number of parameters. Okay, now let's go ahead and train this model here. So training is complete. Let's plot the error. There you go. Looks fine. It looks fine. As I have not changed the epochs, this is still 500. So let's go and print the loss. So that is how we actually understand how it did. So as you can see, the training loss is a little bit higher. It's 4.61. The test loss is a bit higher as well, 16.25. So not much change, as you can see, as we did not reduce the neurons significantly. Therefore, there is not a significant impact. So we can also try to reducing the neurons further down. So let's make this 16. Let's make this 8, and let's compile. So as you can see, the number of parameters have changed. Obviously, now this should have a significant impact on the output. But again, due to the random initialization, you may not catch it in the first run. Let's plot it now. As you can see that, of course, it's a bit higher, the error. Let's go and print it. So as you can see here, the error is much higher, 6.86, and the testing loss is 19.57. So as you can see here, it's almost getting close to 3 grand, and this is almost at 1900. So what we understand is by reducing the number of neurons, we actually reduce the capability of the network in solving the problem.